Hello, this is Mr. Claudy, and today we're going to be going through section 7.4, which is on Ohm's law and resistance. Now this is 7.4, we skipped 7.3, and we're going to deal with those concepts next week. Resistance is the final of the three important things when we deal with electricity. The first was voltage, which is how much energy or juice an electron has. Current, which is how much electron flow there is. And then resistance, which is something that impedes the movement of electrons or slows them down. There's a really crucial formula. The other two formulas are very theoretical, but this is one that's very practical, and this will follow you through your whole career in any sort of electricity. V equals IR, or Ohm's law. This is the relationship between voltage, current, and resistance. Remember, resistance is how much something impedes the flow of electricity. So let's do some examples here. So the current going through a 7-segment display, that's like a display on your calculator, is 12.5 milliamps, so a very small amount of amps. If the source voltage is 3.3 volts, calculate the resistance. So the voltage is 3.3 volts. The current is 12.5 milliamps. I should convert that. 12.5 times 10 to the negative 3 amps. Or it's basically a very small number, right? I move the decimal place over 3. And we're trying to find R. So think about this. Like, you've taken this light up display, you've connected it to a voltage, and a certain amount of current will flow. Like, the resistance of this display is fixed, the voltage is fixed, and the current kind of comes out of those two things. So if I know what the current is, I know what the voltage is, I should be able to figure out the resistance. I use my formula V equals IR. Sub in my numbers, so I get 3.3 is equal to 12.5 times 10 to the negative 3 times R. So you can divide both sides by 12.5. So I have 3.3 divided by 12.5 to the power of negative 3. And I get R is equal to 264, and the unit for resistance is ohms. It's that kind of neat symbol, omega, from the Greek alphabet. So it's drawn like a little O with these little hooks on either side. Now let's continue. The resistance of a person's skin can be as low as 1,000. I always think this is an interesting example because it shows exactly how what would happen if you were to touch an electrical outlet. As you know, the electricity voltage from electrical outlet in Canada is 120 volts. So 120 volts, that's how much juice the electrons have when they come out of the wall. And we know the resistance can be as low as 1,000 ohms. So we want to figure out the current. Remember, I told you current's the dangerous thing. That's the thing that can kill you. So V equals IR. Let me sub in these values. 120 is equal to I times 1,000. So we have 120 divided by 1,000 equals I is equal to 0.12 amps. That doesn't seem like very much. But remember what I told you last week. Current can kill you. A very small amount of current can kill you. Actually, anything over 0.1 will result in death. I mean, below 0.1 is very dangerous too. You could go into shock or paralysis. But this is definitely death. So the person would be electrocuted. So not great. Don't touch an electrical outlet with your bare skin. Now the okay. Okay. Now your resistance of your skin changes, and actually it can change depending on a lot of factors. But if you had a cut in your skin, or you had like just come out of the rain and your skin was covered in water, you would have less resistance. And you'll learn on the last page how things can cause resistance to change. So in this case, you have a cut, so the resistance is a lot lower because there's more of a path for electricity to travel through your body. So in this case, the voltage is 120 volts. The resistance has gone down to 300. What happens to the current? Well, let's use V equals IR. sub in our values. 120 is equal to I times 300. I divide both sides by 300 and I get 0.4. In this case, the current is even higher. So you can see that there's an inverse relationship. As the resistance goes up, the current comes down. And as the resistance goes down, the current goes up. Now, most people who work with electricity have to wear safety boots, and these safety boots actually increase the resistance of a person because now electricity can't just travel through them. They have these thick rubber soles on the bottom. So let's see what happens when you're wearing safety boots. You touch a live electrical panel. You have a resistance of about 1 million. So what is the current? V equals IR. 120 is equal to I times 1 million. So 120 divided by 123, and I get 1.2 times 10 to the and another way to write that would be 0.00012 amps. So a very small amount of amps. So you can see that the safety boots have made you a lot safer, and that's why when you are handling electricity, you should have gloves, you should have proper PPE like boots on. This question at the bottom, we're going to skip this for now. This is a circuit that we'll know how to do once we've solved once we've done section 3. So we'll come back to this later. Please do some of the problems related to Ohm's law, V equals IR. It's a very easy formula to use, but it is the key to everything in electricity. Good luck, and until next time.